Hey folks, there's a new version of AutoGen Studio, and you could do a bunch of interesting things with it. So for example, you could create a new team, and this just gives you a basic structure where you have just a single agent in a single team configuration. You could do interesting things like from a component library, you can drag in additional teams. In addition to that, you could do things like sort of change the models that are associated with each of your agents. And similarly, you could do things like add tools from a default tool gallery to the agent. And then finally, you could sort of modify the termination conditions sort of associated with how the teams run. So in this case, we'll change this to an or termination condition. And once you're done with all of these, you could save that. And right in this build interface, you could test that team. So for example, you might say something like, what is the height of the Eiffel Tower? And in real time, the agent, the entire team configuration gets run. All of the messages exchanged are sort of visualized in this message flow UI. And when the task completes, you see that update here. And you sort of see the reason why the task completed. In this case, it says the maximum number of turns has been reached. So there is a graphical user interface on top of the team configuration, but underneath, AutoGen Studio provides a DSL, declarative specification for agents, and this is what that looks like. And that's what we'll be talking about in this video. Let's get started. So the first thing we're going to cover is installation, right? And I think this is probably the most important bit. And I always recommend that you start out with using a Conda environment. And so what I have right now is a completely new GitHub Codespace environment. We have Conda installed. So Conda is a virtual environment for you to have multiple Python installations. And then another alternative you could use is virtual environment VM. So here we're going to say Conda create -n AutoGen Python is equal to 3.12. What this just says is that we want a Python environment that's based on the Python 3.12 environment. And once we create that, the next thing we do is to activate it. Okay, so we have it installed. So we'll say Conda activate AutoGen. I mean, the name of the environment could be anything. Let's clear it out. And then to install AutoGen, we do pip install -u AutoGen Studio. And now it starts to download everything that we need. And we are a bit confident here that all of the installation is done in a new Conda environment, which is isolated from all other dependencies that we might have on this machine. Great. The final thing you want to do is you probably want to set up an OpenAI API key. And so for the rest of this video, we'll use OpenAI API key. So you want to do something like export OpenAI API key is equal to your API key. And so the reason why this is helpful is because across the AutoGen framework, whenever you use an OpenAI model client, it will by default attempt to use a key from your environment variable, and that just simplifies the process of sort of setting up your key. And so definitely do that. We will need it across the rest of the tutorial. So now we have AutoGen Studio installed. What we want to do is run it. And so the command for that is AutoGen Studio UI. And so we specify the port we want to run that on. So --port 8081. You can also specify a host. The other thing we want to do is we want to define the application directory where all the files are stored. And so if you've had AutoGen Studio installed on your machine previously, I highly recommend you set this parameter to a new folder. So in this case, we're just going to say /my directory. And so it will create that directory if it doesn't exist. So the reason why you want to do this is previous versions might have data structures or database that's incompatible with your current version. And so it's recommended that you sort of start in a new environment. And so once we run this, it should set up AutoGen Studio in the background, and here it says startup is complete. you can navigate to this URL in your browser, and we can open that up, and then we get an interface that looks like this. Okay, great. Okay, so let's go through a quick start. And so once you have things installed, you might notice that you have in your session view, you have a default theme selected. And so AutoGen ships with 3 default themes, multi-agent themes, and I'll sort of talk about what those look like in a minute. And you can select this little arrow down here to select what theme you're going to use. So right now we have only the default theme in our list of themes, and we can create a new session. Think of a session as a container that has multiple runs. And here we can ask the question, what is the height of the Eiffel Tower? And so once we ask that question, behind the scenes, what happens is that the socket connection is opened up with the backend. The theme configuration is set up, and then the agents are sort of loaded into memory, and they sort of start running to address the task. And as they sort of act, all of the messages that they send are sort of streamed to the user interface. So here we see that the assistant agent, which is one of the agents in this team, said that the Eiffel Tower is approximately 330 feet, and it also responded with terminate. And then we see that the task is completed, and the stop reason is that like one of the agents mentioned terminate. And on the right, you might have noticed this, it probably went by really fast. Essentially what just happens is that as messages sort of are streamed, as the agents sort of run, we construct a control flow graph of those messages. And so what we see here is that the user gave a request, the assistant agent responded, and so in this case said that the Eiffel Tower is this large. And essentially, because it sort of responded to itself, we have this sort of self loop setup going on here. Here we run a basic theme. What actually is the theme? What are the agents inside? What does the configuration look like? And to sort of make sense of that, we can go to Theme Builder. Okay, so this is the Theme Builder interface, and here we see that we don't have any themes created so far. And we also see that we have 3 themes in the gallery, and the expected behavior is that we can use any of the items in the gallery as templates, and we can say create from gallery, create a template. And when we click on this, we see like a little nice visualization, and what that just tells us is that here on the left we have a theme. In this case, it is a round-robin group chat theme, and this is a concept that comes from the AutoGen Agent Chat library. If you're not familiar with that, I really would recommend you sort of take a look at an introductory post I sort of wrote about that. And this theme has a single agent in there. So this link here indicates that agent. It's a single assistant agent that has a model and a single tool. And this is a graphical representation, a drag and drop representation of the theme. But if you wanted to look at the declarative specification underneath, you could toggle this little switch here that says JSON mode, and you could sort of see exactly how these theme is represented in JSON. So for example, if we remove the tool here, so there's a default calculator tool in here, and we saved this and we went back to the graphical view, we will see that we actually don't have any tools here. The next thing we can do is that we can right in the theme builder interface, we can sort of test this theme. And so if we click the test button, we could sort of give this theme a task. And here, similar to what we saw earlier, again, the agent responds. But what if we ask something like, what is 256 a really large number times some other number, some other very large number? Here we see that like the LLM sort of, it gives some response which is most likely incorrect. And ideally we don't want like behaviors like this. Instead we want a tool. And so right here, what we can do is, assuming we have the right tool in our gallery, in this case we have a bunch of tools here, we can drag in a tool like the calculator tool. Similarly, we save that, we create a new test session, and we say something like, what is given number multiplied by some other number. Let's remove this little letter here. And then what we expect is that this agent, rather than just hallucinating some number, it actually uses the calculator tool, and then it returns a response like we expect. Okay. In addition to that, we could also use things like create like teams from the templates we have here. And so here's a web agent team and a deep research team. And let's just go over what's the content of these teams. And so here for the web agent team, it is a selected group chat with a selector message that sort of describes how the agent sort of orchestrates the flow of control between each of the agents in there. And it says something like, you have the following roles. The web server agent will be tasked to address, the web server agent will be able to address tasks by browsing the web, and the assistant agent will be tasked with verifying the progress of the task. And if there's a user, there's need for feedback from the user, we can defer back to the to UserProxyAgent. And we can see that here we have 3 agents in here. First is a multimodal web server agent. It has a GPT-4o mini model. Next, we have an assistant agent, and it's mostly just for verifying the progress of tasks. And then we have like a UserProxyAgent. And as usual, right here we might run a test, and we might say something like, go to Amazon and find me the prices and links of workout earbuds under $50. And so underneath, because we have a web agent, and so this is an agent that primarily addresses tasks by driving or controlling the web browser. Just in time, AutoGen spins up a web browser underneath. You see it's putting the search on bing.com, workout earbuds under $50. And then the assistant comes back with some notion of like, hey, here's what the task is all about. And next it says go to Amazon, and then it goes down to Amazon. It looks like the web page here. And then the assistant agent comes back and says that like the task of finding is still not fully completed. The web server has accessed the relevant Amazon page but hasn't listed the products. And as all of this interaction goes on, we can see that like the control flow of messages is being visualized here. And then the web server still continues exploring. In this case, it has drilled down into a specific earbud web page. And then at this point, it delegates to the user. It says, the assistant agent says, here's the information about the workout earbuds selected. It says, here's the price, here's the prime delivery, here's the ratings. And this sounds good to me. And so as a user, it's delegated feedback to me. I feel satisfied. I might say something like terminate. And so this is an example of just in time, delegation. Control is delegated to user proxy, and right there in the UI, a text box sort of shows up, and then the users can type a response. You probably will also notice a countdown timer here. This is just done such that if no response is provided, the socket connection on the backend gets cancelled and resources don't continuously stay open. So this looks good to me. Everything is completed. A bunch of messages were exchanged, and finally the user proxy got final. I gave some feedback using the user proxy agent, and then the task got terminated. Okay. We can also sort of test out the deep research agent, and it is very, very similar to the web server agent, except in this case there's no it's similar to the web agent team, except in this case we don't have a web server agent. Instead, we have a base assistant agent that can address tasks. It has access to a Google search tool and a fetch web page tool. The second thing is that we have a verify agent that's mostly, the task here is to provide feedback. Has a task been completed or not? And we just have a summarization agent, and its main task is to sort of when the entire task is complete, to generate a report. And so let's have a simple task here. let's give a simple task to this agent team. Let's test it out. Who is Jeff Dean? And can you give me a list of the top 5 papers he has written? Let's see how it does here. And so here it says, we're gonna use a tool, conduct like a search using Jeff Dean top 5 papers. The results come back. The verifier has like some type of product progress assessment. I think it has directed the research assistant to use Google Scholar. Let's see how that goes. It says at this point, the verifier says like the Google Scholar profile shows all of the things that we need. So there are no gaps. We just need to provide a final summary, and essentially that's what gets done. A bunch of messages exchanged here to get that task done. We see like it's 12,000 tokens here, 12,000 tokens here, 17,000 tokens until we end. And then there's a little report at the end. Let's take a look, which is shown up here also. It says like Jeff Dean is a pioneer in machine learning distributed systems, top 5 most influential papers, does all this stuff. Probably should check it for correctness, but anyway, all very, very interesting. And of course, as you try this out, one thing I should state very explicitly is that all of this works well because we use the GPT-4o model. So this is a fairly capable model, and it's really able to follow instructions really well. So for something like a selector group chat team, if we select edit, we can take a look at the selector prompt. And so this is what guides the behavior of how the next agent is selected. These are fairly complex instructions, and small models, let's say in the 7 billion or 14 billion parameter models, size might not do that great. And so just be mindful of that as you work. I mean, they could be made to work, but not without some additional fine tuning. And as you sort of explore new use cases, also be mindful that you might need to sort of update some of the system messages of these agents to sort of get the behaviors that you are interested in. Okay, so so far we have looked at examples, tested a couple of examples where we used OpenAI models. But in theory, you can use other types of models as long as they provide an OpenAI compliant endpoint. And so providers or tools like LM Studio or Ollama or even DeepSeek, they all have OpenAI compliant endpoints. And on my local machine, I do have an LM Studio endpoint that I have a Mistral 7B instruct model sort of running. And let's see how we can configure that. And so here in our library, we have a default Mistral 7B config, and we can drag that in here, and we see that it replaces our GPT-4o mini configuration. So we can save it, and we can go to the JSON and sort of take a look at what that looks like. So here under model client, this is an important bit here. It says we're using the OpenAI chat completion client, and for configuration, we have a model name, which aligns with what I have in LM Studio over here. We also have an important field that AutoGen uses to sort of figure out how to the properties of this model. So you kind of have to add that. So for example, this model does not support vision. It's not a multimodal model. It says here that it supports function calling, JSON output. It doesn't support that, and it's an unknown family of models. So once we have that, we can then, as usual, let's open up our little team here, and we can say what is the height of the Eiffel Tower, and you can see our Mistral model is sort of fired up, and that sounds good. And so we might say something like, what is this times this? And you see our local model is working really hard to attempt to address this this query. It might take a while, but the interesting thing is you can cancel this run at any time and sort of explore the things. And this is one of the particularly interesting benefits of the updates to the AutoGen underneath API. It's completely asynchronous, and so you can always cancel tasks that are sort of headed in the wrong direction. Okay, so we have covered all of the features so far. I think the last thing to cover is the idea of a gallery. And think of a gallery as a container of items that you can reuse. It has things like themes, agents, tools, models, and termination conditions. And the idea is that you can have a default gallery, but it does not always have to be what ships with AutoGen Studio. As folks sort of explore, build more of these types of galleries, you can always sort of import new galleries. For example, if you click import, we could import from a URL, and so this is just a URL to a web page that I have, and we can say import from a URL, and that gallery gets imported. You could also do things like drag in a file or paste the JSON. It just needs to adhere to the gallery specification. And then finally, there's a section on deployment and how all of this works. And there's a really useful tutorial I really encourage you to explore. So the first piece here just shows that, like, if you define an AutoGen theme, agent chat theme in Python, you could essentially get the configuration of that theme. So you call the theme.dump component, and if you sort of converted that to JSON and wrote it to a file, you get the exact same specification that you had here. And so once you get this JSON specification, you can pretty much copy it, and you can head over to theme, hit new theme, switch to JSON mode, paste that in here, and you get the exact same functionality that you have in Python. And so you have like almost one-to-one operability of behavior between what you can do in agent chat in Python and what you can do in agent chat or in AutoGen Studio. So I think that's a really, really powerful concept. Of course, there's some small, some tiny caveats there. All of this will work with standardized components in the agent chat library. If you have custom themes, there's a way to make them configurable. So there's a way to make them compliant with this dump component configuration. Your components just need to inherit a couple of classes, implement a couple of methods, and then they will be compliant with the dump component interface. Okay, so this brings us to the end of this video. It's probably got really long, and as usual, if you are interested in learning more about multi-agent systems, the multi-agent book is a good place to start out. So for example, there are a bunch of like example code labs. So for example, all of the code for deep research agent that we saw, it's all available here. You can sort of take a look, and you can view the exact source code on GitHub. And similarly with the web agents, browser interface agents, you can also sort of look at all the code on multiagentbook.com. So yeah, see you guys in the next one.